Hello everyone. Today we will see assembly language program to transfer 10 data stored from 30H to 40H locations by using method 3. Earlier we have seen method 1 and method 2. So this is method 3, also called as loop method. Here this method, it is used to transfer 10 data values stored in memory locations from 30H to 40H locations, that is to a new memory location. This method, it uses a loop to repeat the data transfer operation, making it more efficient and scalable compared to method 1 and method 2. So here, now why this method is more efficient than method 1 and method 2 is, it uses a loop to repeat the data transfer operation, making it more efficient and scalable compared to method 1 and method 2. And here the first advantage is scalability. The loop method is much more compact and scalable compared to manually specifying each data transfer. If you want to transfer more data, you would only need to adjust the value of register R2 here, okay, and the memory locations. And second is compact code. Using a loop reduces the number of instructions, making the code more compact and more efficient. For example, instead of writing 10 separate instructions to move data from 30H to 40H, the loop executes the same process for all values with just a few lines of codes. And third is automation. This method it automates the process so that it can be easily adapted for different sizes of data transfers by adjusting the loop counter R2. Okay, here we'll be using the loop counter R2. I will explain that in the program. So this is the program for loop method. Here we are using these two instructions, that is move R2 comma 0AH and move R0 comma hash 30H, three instructions, okay, and move R1 comma hash 40H in the first part. Then here there is a loop. In this loop we are using move A comma at R0 and move at R1 comma A. These two instructions allow the program to read from one memory location and write to the another. So by using the registers R0 and R1 as pointers, the program can access successive memory locations easily. Then here we are using another instruction called as decrement R2. It is used as a loop counter here. Okay, R2 is used as a loop counter. Initially we will set up R2 to 10 because we are transferring the 10 data. Okay, if you are having more data, you can initialize this to that value. Okay, if you want to transfer only 5 data, you can initialize R2 to 5. Here we are initializing R2. R2 is initialized as 0AH, that is 10. Now when R2 becomes 0 in this loop, when R2 becomes 0 after decrementing, then the loop will terminate. And another instruction which we are using is the JNZ up. Okay, jump if not 0. If this counter is not 0, then it has to jump to this location, that is JNZ up. It checks if the value of R2 is non-zero. Okay, if it is, then the program jumps back to the up label to repeat the transfer. If R2 becomes 0, the loop exits and the program moves on to the infinite loop at the end. So now we will see the program. Here again you have to do the initial setup, that is org 0000H. Then you have to load the source and the destination address. Now here move R2 comma hash 0AH, it will load the value 0AH, that is in decimal it is 10, into the register R2. This is the counter. Okay, this is the counter that will keep track of how many data items have been transferred. And because we have initialized this, or we have loaded R2 as 0A, that is 10, this loop will execute 10 times. This loop will execute 10 times. Then the next instruction is move R0 comma hash 30H. This will load the source address pointer R0 with 30H, where the first data value is located. Next instruction is move R1 comma hash 40H. Here it will load the destination address pointer R1 with 40H, where the first data value will be copied. Okay. Now, next we'll come to the data transfer loop. Here we are using up up. You can use any label of your choice. Here I have used up up. This is the label for the start of the loop. Next instruction here is move a comma at R0. So the value from the memory location pointed by R0, that is the source address, it is loaded into the accumulator. Next is move at R1 comma A. The value which is there in the accumulator is stored into the memory location pointed by R1, that is the destination address. Next is increment R0, that is the source pointer R0. It is incremented to the next memory location, so it points to the next byte. Then the next instruction is increment R1. Here the destination pointer R1 is incremented to the next memory location, so it points to the next destination byte. Then you have decrement R2. Here this is the loop counter and it is decremented by 1, and this will keep track of how many data items have been transferred. The next is JNZ up. So this instruction it is used for if the loop counter R2 is not 0. This is not 0. That is, there are still data items left to transfer. Then the program jumps back to the label up and it will repeat this process. Then you have H colon S jump H and end. So here this will this instruction, this S jump H, it will create an infinite loop at the end of the program to halt the further execution. Okay. So this is the loop method, and this loop method, it is highly efficient and scalable way to transfer the data between the memory locations in assembly language. By using register indirect addressing and decrementing loop counter, the program efficiently transfers 10 bytes of data from the memory location 30H to 39H to the memory locations 40H to 49H without the need for repetitive code. Now we will see the execution of this program. So here we will open the Keel software by double clicking on the icon. Go to project, new project. I will use the previously used or created project Alice. Save. As I have created it earlier, it is asking whether I want to replace it. Yes. Now select the device, microchip. Click on this plus symbol and search for 8089 C51. Okay. 8089 C51 you have to search. then click on OK, click on No. Now go to the file, click on New File and write your program here. I have pasted the program. Now you have to save the program with the .asm extension. This is method 3, or I will name it as loop method .asm. Then save. Now click on this plus symbol here at the target 1. You will get source group 1. Right click on this and click on add existing files to group source group 1. Now search for your program, that is the loop method.asm. Select it, click on add, click on close. Okay, now see whether your program has been added. In the source group 1 it has been added. Go to project, click on build target. So you can see here there are 0 errors and 0 warnings. Go to debug, start or stop debug, click on OK. Now here in the first memory window we will give the input at 30H location. So I:30H. Okay, I will take another memory window to see the output. So here I'll take memory 2 and I'll take the location as I:40H. Okay, here I'll give the input 11, 22, 33, 44, 55, 66, 77, 70, I'll write 88. You can give any input. 99, 10. Okay, so these are the 10 inputs which I have given at different memory locations, that is 30, 31, 32, 33, 34, 35, 36, 37, 38 and 39. Now we'll go to debug and we will run it. Before that I will go to memory window 2, then I'll run it. So you can see here earlier there was no data in this. Now you have got 11, 22, 33 which was there in memory window 1 at 30H location to 39H location. Here also you can see, that is this is here also you can see, that is 11, 22, 33, 44, 55, 66, 77, 89 and these are also at 40H locations. So you can see this easily in the 40 in memory 2 window, that is we have started from 40H location. Okay, I will stop it and we will see the step-by-step execution of this. Now I'll go to debug, start or stop debug session. Okay. So memory window 1, that is memory 1 window, sorry, 11, 22, 33, 40, 44, 55, 66, 77, 88, 99 and here I'll take it as 10. So I'll take memory 2 window to see the output. We'll press here on this icon, or you can press F11 on the keyboard. Now see here. Okay, now the memory now the counter, okay, that is R2 is nothing but 0AH. Okay, we have initialized the counter to 0AH because we want to transfer the 10 data to one memory location to the other memory location. Okay, so now again click on this icon, R0 is nothing but it is 30. Yes, no, R0 is 30. Next again click, then R1 is 40. Okay, so Again you click here. Now you are getting accumulator. Okay, in accumulator you are getting it as 11. Whatever was there in 30h location, it has been transferred or it has been loaded into the accumulator. Next, again click here. Now from the accumulator it will be transferred to where? To 40h location, that is 11 here. Okay, now it will increment R0 and R1. Earlier R0 and R1 are 30 and 40, that is the source and the destination addresses, 30 and 40h. Now R0 is incremented, so R0 becomes 31. Then R1 is incremented, R1 becomes 41. Okay, now it will check whether R2 has become 0. No, sorry, it will decrement R2. So R2 has become 9. Earlier it was 0 AH, that it was 10. Now it has become 9. Now next click here. So because R2 is not 0, it will again jump to this memory, to this level, which is at your 6th line. Again this loop will execute unless and until this R2 becomes 0. Okay, you can see here next 22 is loaded into the accumulator, and after that you get here in 41h as 22, which was there in the accumulator. Now it has come into 40h location. Then again R1 R0 will be incremented, it will become 32. Then R1 is incremented 42. Okay, then R2 is decremented. Previously it was 8, now it 9, now it has become 8. It is not equal to 0, therefore again you will get the cursor see here. Okay, then again it will jump to this level and it will continue the process until and unless it becomes 0. Now you can see here R2 R2 value is changing, R1 is changing, and R0 and R1 are changing. Now just I'll show you. R3 sorry, R2 has become 3, it has become 2, now it has become 1, that is the counter. Still it is not 0, therefore again it will go to this level up. Again you execute. So now it has become 0, R2 has become 0. Now you click on this, it will not jump to the label. Okay, instead it will go to the next instruction. So here it has come to what? It has come here at the 12th line, that is ending the program. Okay, it will enter into the infinite loop and it will end the program. So this is about the method 3, that is the loop method. I'll stop this. Stop. Okay, so we have seen 3 programs in order to transfer the data from one memory location to the another memory location. First was the loop method first was the method 1, and then there we have used many instructions just to copy the uh, data from one memory location to other memory location. Then you have method 2, okay, where you have used register indirect addressing, where some number of instructions were reduced. Now in this method is more efficient because here you are using less number of instruction and the time required for execution is also less. And here you are executing a loop and you don't require more number of instruction in this. I hope you have understood these 3 programs. Thank you.